Welcome back. My name's Ian. If you weren't in the other session earlier on, Ian Massingham. I lead technology evangelism at AWS. Quite a few of the people here today that are delivering the real technical content are in my team. As I joked in the other room before, they give me the less technical stuff to do now. It's like a feature of seniority. The more senior you get, the less the team want you to actually touch anything that operates anything. Kind of weird that, but I get to give a few fun talks. Does everybody in this room use Facebook? Does everybody in this room have Facebook Messenger installed on their phone? Okay, you will be required to participate in a demo later which involves using Facebook Messenger. So if you do not have it, it's a good idea to get it. The success of this session hinges on the fact that a few of you are prepared to participate in that, okay? If nobody participates in the demo, I'm going to look stupid, and you won't be able to see quite a few of the features that I'm going to talk about. It's a participatory session. Okay, in fact, I went to Katowice in southern Poland for my last talk of 2017. This was on the 16th of December for an event called Cloudinia, which is actually a conference organized by our equivalent of an MVP. We call them AWS Community Heroes. And this guy runs this conference in southern Poland every year. Actually, it was in a really nice hotel in the tallest building in Katowice, which is in the far south of Poland. I was the last slot of the day and I was giving this talk. And you'll see when I do the talk, it's mostly demo. There's actually not many slides. It's mostly like in the console. This is how you do things. 2 minutes before I went on stage, the entire projection system went down in the whole hotel. So there was no slides, no demo, okay? But I have the demo, which is an interactive demo. And thankfully, because the people in the audience were prepared to participate in the demo using Facebook Messenger, everything worked. And I was able to get a CSAT, a satisfaction score for the session, which was actually really high, even though I had no, just no display at all. It was all done on a whiteboard. And then by individuals in the room participating in the demo, it actually worked pretty well. So the thing about chatbots is you can interact with them, so we don't need quite so much slideware. Okay, so why did we build Amazon Lex? What is it? How do you get started? Probably when we get to how we get started, we'll just jump straight into the console and start showing you a few things here, and then we'll get you started with the chatbot, interacting with it, and you can get a feel for how it works, okay? Why did we build? Been an evolution in the way in which we interact with applications and actually data sources as well over time. Okay, so we started with machines that were controlled by wizards, like the mainframe programmers. Nobody could get near the systems. You basically submitted your code, often handwritten or on punch cards, to a bunch of operators who would take it, run it, and bring you back a printout with your results, right? That was like the ultimate expression of asynchronous development. You had to wait days to get a printout of your results back. Then we moved to Gen 2, which was all about a combination of skeuomorphism, which is taking the attributes of the physical world and projecting it into a digital interface. So this is the whole concept of you turn on your iPad, you open your notebook app, and it has a fake ring binder down, or spiral binder down the left-hand side. So that's real sort of the extreme end of skeuomorphism. But in the functional sense, it's like my files are organized into folders and live in a hierarchy. To open them, I click on a filing cabinet. To scroll down my display, I drag this slider down the window. So it's the classic elements of the GUI that were introduced, researched in the late 70s, and rose to popularism in the 80s and 90s with advanced systems like Windows 3.1, which at the time was really groundbreaking. Early versions of macOS, really, really revolutionary, getting away from the terminal, from the CLI, and into visual interfaces, which opened up information systems to a much broader audience, actually. You didn't have to remember commands. You could remember visual analogs and user systems in that way. And then from there, we've moved on again, Alexa, play Black Magic by Little Mix. A phrase that is heard in my house hundreds of times a day. Most popular utterance across my little farm of Alexa devices that I have a 7-year-old and a 5-year-old. They're big Little Mix fans, and the catalog is churned constantly. They don't need to switch a machine on, okay? Just like I don't need to switch a machine on to turn on the lights in my lounge, or set an alarm, or check what the weather's going to be for Helsinki on Thursday this week. Just ask Alexa, and you get responses back, okay? That's the conversational interface. And we were early with that. We were early in launching the Amazon Echo, early in launching the Alexa voice service. Those are products that have been around for, I think, over 3 years now in the US, and obviously available in US English, available in the UK, available in Germany, available in Japan. We have a new language model for English in India for users in the Indian subcontinent that want to use the device, and it's available there. And we just announced much increased global availability of the physical product, the Amazon Echo, in a lot more countries around the world. As long as you're prepared to use one of those languages, we'll ship the device internationally now. And that's partly a feature of licensing for devices that have Wi-Fi connectivity in them. I'm sure you know that you can't just enter a market and sell a product that's got a radio. You have to go through a regulatory cycle to do that, and we're expanding availability of those devices as we do that. But with the Echo, with Amazon Alexa, the conversational interface is tied to a physical device. For most users, you can actually incorporate the Alexa voice service in your applications. And there's been quite a few examples of projects that developers have built that make use of the Alexa voice service, but do not use the Echo hardware. In fact, in the keynote at AWS reInvent this year, no, not reInvent, at Web Summit actually in Lisbon earlier this year, which is a massive event for the startup ecosystem here in Europe. The CTO of Amazon showed a video of a fish with a Raspberry Pi inside it, and the functionality of the Amazon Echo was available in this talking fish that you put on your wall. So you could say, ask it things, and it had the Alexa voice service built into it, and it was animated, so when it answered, it would sort of wiggle around on the board. Kind of weird, but just proves that the Alexa voice service is actually decoupled away from the hardware, and lots of developers today building it into other devices. Just at CES quite recently, there were several announcements of new products that have the Alexa voice service in them, and also automotive's a big field here with manufacturers of vehicles putting AVS into the vehicles, so you can communicate with Alexa, communicate with the vehicle by using the voice platform. But you're tied into a particular ecosystem there. The other thing that we heard from developers is just generally opening up conversational access to applications without having necessarily having the requirement to have a full-blown Alexa capability deployed into your app. Also something that developers are interested in. There's a couple of different use cases here. First is just having mobile apps that have better accessibility features. You know, traditionally to use a mobile app, you're talking about a touch interface. It's not great. Actually, it's not great if the weather's cold and you want to wear gloves, something as simple as that. But it's also not great if you're driving. It's not great if your mobile app is used in a context where people's hands aren't free. Maybe it's an industrial app that is used in the workplace where people are doing something else with their hands. Operating equipment or driving a vehicle would be the classic. So you want to have voice features, but you want to have them within your application for a specific use case. So that's one example. Second example is actually taking these conversational interfaces to the locations where your customers or users are already present. And this is the classic example with Facebook Messenger and with other chat platforms. The customers are already out there. The customers have already got those applications installed on their phones, on their devices. They're already using them within other apps. So if I can take access to my conversational interface out onto that platform, how much easier does that make it for my customers to interact with my applications? Well, we think substantially easier, and a lot of developers are really interested in that. A lot of businesses are really interested in that. Getting their apps out into the environment where their customers already exist, where their customers already communicate with other people, with other brands, and making the applications, making the information systems more accessible by doing that. So that's really the challenges that we're trying to solve. From a developer perspective, there are quite a few things here that are difficult. When I talk about conversational interfaces, of course, I'm not only talking about speech, I'm also talking about the text-based conversational interface, and that's what you're going to interact with a little bit later in the demo that I'm going to show you. Speech is one thing, language understanding is another. So first of all, you have to figure out what's being said. So the words that have been spoken. And then regardless of whether or not you're using that input or using text-based input, you've got to resolve that down to some meaning. So what's been spoken and what's being meant, they're actually two different things. Okay, we'll talk about some examples of that in a second. And then you have all of this other stuff, all of the things associated really with building distributed systems. And these are amplified to some extent with the kinds of approaches that I'm talking about. If you make an application available to voice-based access, what are you doing? Well, you're unlocking it for access by a hugely broad range of different users that might not normally have used it. It's what you see with young children using the Echo. It's actually what you see with older people using the same kinds of technology. And it's also what you see as a result of the natural accessibility features that are present in these platforms. If you're visually impaired, or you have some other sort of disability or impairment that prevents you from using a touch-based interface, you can still use a voice-based interface. Right? You can still talk to an Echo, even if you're completely blind. So you're opening up usage to new kinds of users. Second thing you're doing with going out onto platforms like Facebook is you're immediately uncorking your application to access by millions and millions of users with very little control over who chooses to access it or who you allow to access it. Once you've got your public API, once you've got your messenger bot, if it becomes popular for some reason, you can face large volumes of traffic, and there's really no way to gate that, no way to control it. So having the right back end, having the right scalability characteristics, having the right security model, it's very important if you're building these kinds of applications in order to avoid dissatisfaction in the customers that you want to acquire, right? So trying to solve those things, we built this service. Characteristics, basic characteristics. So text and speech understanding powered by the same, or actually very, very similar, not identical, but very, very similar technology to Alexa, okay? Deployment to chat services, make it easy for you to take your chatbot and deploy it for voice, and also deploy the same thing on Facebook, deploy the same thing on other platforms, okay? And in fact, provide an interface that enables you to extend accessibility to platforms that we don't support. Okay, I'll talk about some examples of that later. Designing for builders, so trying to create tools that simplify the process of building these conversational models, make it easier for developers that aren't experienced in dealing with NLP to work in the environment, and I'll show you that. And then the developer hygiene of versioning, aliases, the capability to connect back to enterprise systems. Okay, so that's what we've built into the service. You'll see all this stuff in a little while, okay? And the core of this really at the front end is this ASR and NLP, automated speech recognition, natural language understanding. It's worth just drilling into this a little bit because this is one of the most challenging parts of building these kinds of systems. And it really all resolves down to this, the fact that if I want to, let's just say I've got a bot that supports travel bookings. Okay, so I want to have an app where I can say things like, I want to book a flight, or I want to book a hotel. How many different ways do you think I can express the intent of wanting to book a flight? How much data can I pack into that intent, which is relevant to the action of booking a flight? Or how superficial can I make the intent? Simple as book me a flight. I want to book a flight. I'd like to book a flight. I need to book a flight. Please, can I book a flight? I want to book a flight, please. These are all different ways of saying something at the very superficial level. With that, before we start getting into more complex examples, like, I'd like to book a flight from Helsinki to Manchester that leaves on Thursday afternoon with British Airways. Or on Thursday afternoon, I need to fly to Manchester from Helsinki with BA. I need to leave after 1 p.m. Now we're starting to get into real complexity. Or how about I need a flight from Helsinki to Manchester, but the system needs to gather the rest of the slots, the time, the preferred carrier from me automatically without me writing 1,000 case statements or 10,000 case statements or 50,000 case statements to cater for every single possible construction scenario for the same thing. You see how complex this gets and how the level of complexity balloons as we start to need more information within the intents that we're supporting. This is where the deep learning technology comes into this service. it comes into the service in the sense that we can build a language model based on intent and entities. So the intent is flight booking, and the important entities, which we call slots, within that intent are the source or the origin, the destination, the date, the time, the preferred carrier. Maybe there are optional ones like the class of travel or my frequent flyer status as well that I might want to add. But there's some things that I definitively need in order to conduct that transaction, in order to resolve and fulfill that intent. And there are other attributes, entities, slots that are more optional in nature or completely optional in nature. I need a system that will enable me to resolve intents, collect entities or slots, and dynamically generate utterances, dynamically generate interactions in order to fill in the gaps in the model. I want to book a flight from Helsinki to Manchester. When do you want to travel? With which airline? And at what time? There are 3 questions that I need, okay? And if I'm building a lot of these, wouldn't it be good if the deep learning neural network had the capability to generate the language appropriately based on the entity type? So if the entity is a city, origin or destination, it's where or which city. But if it's a time, it's when or what date. You see? So there's this nuance of having a general purpose language generation capability that can create phraseology that is human-like, that sounds like it would sound like if I was conversing with you, if you were having the conversation, if I was a travel agent and you were a client. The way in which I speak back to you is really the essence of humanness within the system, right? So that's what the deep learning neural network does in this case. It does the inbound intent resolution, entity extraction, and it does the outbound, the slot elicitation, we call it. What is it that we need in order to complete the model? Okay? That's really what Amazon Lex is. It's the front end that does those things. Covered a lot of stuff there, which is all on slides that I'm now no longer going to use. So let's jump into the console and I'll show you a few things. This is probably the best way to become more familiar with this service, okay? And there's a few things we can do here. The first thing we can do is deploy a... show my ineptitude at data science here, so nobody look at that, okay? I'm still learning about that stuff. Okay, yeah, I don't need that anymore. So we're in console here, obviously. We're in the US East 1 region, which is today is the only region where Amazon Lex is supported. And you can see that I've already got a bot here present in my account, which is called Session Feedback Bot. And that's what we're going to come to later when we start talking about demos. Okay, so we'll get to that. But let's just say I wanted to create something new here. Maybe I want to create a bot that will satisfy this travel booking use case that I just talked about. That's one of the templates that we have available within the console. Okay, so I can hit create. You see we've got several templates available: book trip, order flowers, and schedule appointment. They have different interaction flows, and you can see those represented at the bottom of the screen here. So what you'll see is a representative example of the interaction flow that is supported by the book trip example. I'd like to book a hotel. Sure, which city? New York City. What date do you want to check in? November the 30th. Are you sure you want to book the hotel in New York City? So it's confirmation of the transaction? Yes. Okay, thank you. The reservation went through successfully, so a confirmation message. That's the flow that is supported by this particular example that we have. And we can deploy it directly into our AWS account just by confirming a role, specifying whether or not this service is going to be used by children, because that introduces additional terms, and then we create it. And what's happening here is the language model associated with this particular set of functionality is being deployed into the service. So we are priming, pre-training an instance of the understanding neural network with the intents and the slots or entities that are associated with this particular use case. We're loading a model into Amazon Lex in order to support this. This just takes a few seconds, okay? And once that's done, you'll see that we have 3 intents that are specified. No, sorry, 2 intents that are specified: book car and book hotel, okay? And we have some additional data which we'll show in the console, sample utterances, and slots. Okay. Once this is done, we'll talk about those briefly. So the sample utterances that you can see now at the top here, these are on the car. Let's jump onto the hotel intent. Okay, so it's a bit more complex. Book a hotel. I want to make a hotel reservation. Reservations. Book a night stay. Book a 4-night stay in London, for example. Okay, all example utterances. These will prime the language model, the understanding model for intent resolution. So when I interact with this bot and I either speak to it and submit the resolved results from the ASR operation, from the speech recognition operation to the API, or I converse with the bot textually, which I can do in real time here in the test console, the meaning of the intent that I've specified is resolved. I then enter a dialog state, elicit slot, which you can see here. I start to work through the slots that are defined within my model and elicit the values that are required in order to conclude that intent, in order to fulfill that intent. Which city will I be staying in? Stockholm. When do you want to check in? Today. Did you see that? So I can use natural language in the dates, and it will then resolve those dates down to ISO dates. Check-in date, 2018-01-23, but I said today. I could say next Thursday, 2 weeks on Monday, Christmas Day 2019. There's a language model there that understands human spoken dates and is capable of resolving them down to ISO dates. And that's where these built-ins down here become important. Not huge, but you see that built in there? That says Amazon date, which introduces the functionality that's required to date resolution, for date resolution to that particular slot value, okay? And so on. There are many others as well. So numbers, postcodes in the United Kingdom and the US zip codes are supported. So we understand the structure of these common spoken data types, and we're able to resolve them and also prompt for them and convert them to appropriate system formats so they can be used within the back-end functionality provided by the system. Okay, so we're offloading a lot of the complexity and heavy lifting associated with building these conversational interfaces. How many nights will I be staying for? I'd like now, watch this, small room, okay? So there it said, what type of room would you like, okay? And I entered small, which isn't one of the valid options. The valid options are queen, king, or deluxe, okay? And I said small. So you can see there that validation is not a feature of this front-end model, of this particular language model. There are no validation features there, okay? So, but I can still confirm that state, even though it hasn't been validated. In state ready for fulfillment. Okay. Yeah, okay, so that's been fulfilled now. A little bit of a lag there on the interface. So what about adding things like validation? And what about adding the actual back-end logic that's required to fulfill the intents once we've collected all of the data that we need to do? So how do we go about doing that? And that's pretty obvious from the console, actually. See, there's these two sections, Lambda initialization and validation, and Lambda fulfillment. Okay, so what happens is you can configure Amazon Lex to invoke Lambda functions each time a response is received from the client or from the speech recognition service. Okay, so that means when I change state from pending a response to receiving a response, I can trigger a Lambda function at that particular point in time. And that Lambda function is going to receive a fixed format document from the Lex service, which is a JSON structure that contains information about the dialog state, let's say. So it would say, for example, there's a full documentation set for this, but might say, for example, fulfillment. So we're ready to fulfill, okay? And there'll be the slot data will be packaged up within that object and sent to the Lambda function in a defined format. So I can therefore write a Lambda function that expects to receive those API requests in that defined format, process them, and respond to them with another fixed format document that drives the Lex service. Okay, so by using this back and forth with these two document formats, I'm capable of enriching the chatbot with a lot of additional functionality for things like slot validation. So if booking a hotel is my use case, it's obviously impossible for me to book one in the past, right? And if providing feedback on something that's already happened is a use case, it obviously shouldn't be possible for me to do that for a date in the future. So I can write my own validation logic, which extracts and interprets the slot values that I'm receiving at the back end, and then resets them and reprompts the user to provide new values if I'm entering values that are impossible or out of bounds for my particular use case. So that's something that I can do. The second thing that I can do, of course, is I can fulfill, once I've got all of the information required to fulfill my particular intent, I can fulfill. And I can fulfill by interacting directly with another API endpoint. I can fulfill by inserting the fulfillment object into a Kinesis stream for asynchronous fulfillment. I could fulfill simply by depositing an object into an Elasticsearch cluster if all I'm doing is visualizing data that's being collected by the chatbot. So I can essentially interface my Lambda function for fulfillment with other systems at that point, and that's the most common way in which this service is used. Okay. So, wiring in a fulfillment and initialization and validation function is actually very simple. So we're going to open the Lambda console over here. We're still in North Virginia. We're going to create a new function. We're going to use a blueprint. We're going to search for Lex. You should see the booktrip Python function is here. Oh, not Node. Booktrip Python, yeah. I'm going to deploy this into my account. Oops. This is the code, which I'm going to return to in a few minutes and show you in an editor. I'll create that function. Okay, that should be provisioned. Jump back into the Lex console, Lambda initialization, and reload that. Okay, so what I did there obviously was quickly deploy that template, modify my two intents so that the Lambda function is being called initialization and validation. So that turns on invocation of that Lambda function each time the dialog state receives a response, each time the bot receives a response from either the ASR or chat interface. And also hook the same function up for the fulfillment action. Okay, so I'm triggering that Lambda function each time I hit one of those two states. And we'll just take a quick look at the code for that Lambda function as well. This is not it, this is something else. So okay, so we can see what we have here at the bottom is this simple intent router, okay, which is here. So when I receive an invocation, I receive the event. Now the event is the metadata document, JSON document that comes from Amazon Lex that's just posted into the API, okay, posted into my Lambda function as the event. I unpack that, and in unpacking that, I'll find an attribute in there called current intent name, okay? And by checking the value of that attribute, I can establish which intent is being referenced for this particular invocation. And then I can select, invoke specific logic associated with that intent. So you'll see here for the book hotel intent, I am reading the slot values associated with that intent. So these are the slot values that have been populated in the front end through that conversational back and forth. Okay, I have session management component here. Okay, and then I'm going to validate those slots. So I'm going to look at things like the dates that I talked about earlier. I'm going to look at the target cities to establish that the cities are supported, and any other logic that I build in there. Okay, and if I have slots that I determine are invalid, okay, I can reset them, which I'm doing here by setting them back to none, so effectively clearing those invalid values. And I'll use this helper function called elicit slot. This generates a document that I send back to Lex, which drives the front end to reprompt for that slot that I've determined is invalid. Okay, and if we zip back up the code base, you will see what I am returning back to the Lex front end is another object containing session attributes, how I pass my session state backwards and forwards and maintain my session state with that particular user. Okay, so I know which slots they've already populated, for example. Okay, and then this dialog action object, which contains a type definition, elicit slot, telling the front end that the next thing you need to do is elicit a slot, giving the intent that we're working with, okay, specifying the slots that are already populated, specifying the slot to elicit. So this might be the booking city or the check-in date, for example, and then providing a message that I want to relay out to the client in order to reprompt for that particular slot. This can be a customized message, of course. We might see that further down the code base if you look at dates. These are the messages here. So I did not understand your return date. Your return date must be after your pickup date. That's all related to car bookings. Did not recognize that room type, for example. Okay. So if we jump back into the client session now, and we'll go book hotel again. Okay, which city will I be staying in? New York. Last Monday. Reservations must be scheduled at least 1 day in advance. So here we can see our slot validation logic is in play. Okay, we're sending the we're sending the slot data to that Lambda function for validation, and we're receiving responses back, which cause re-elicitation for slots that are invalid. This is how we enrich the experience, make the experience more human-like, and of course implement our business logic in the back end as well. Okay, so that's it. It's really that simple. Language model in Lex Console, okay? Additional validation operations and business logic in those Lambda functions that sit behind. You want to see it in action and experiment with this a little bit more. Let me show you something else. Okay, go here. Okay. Open Facebook Messenger and search for this, ian.messingham.aws. Or alternatively, if you've used this feature in Facebook Messenger, if you go to people in Facebook Messenger, you can scan a contact card. And if you scan a contact card, you'll find my client there. Okay, so I'll just explain precisely how to do that. Yeah, if you go into your Facebook Messenger app, you'll see this people button on the side here. At the top right of that screen is scan code. You can literally just point that code at that. And in normal cases, that will find the endpoint. You can chat to the endpoint. Has anybody deployed messenger bots on Facebook before? Do you want me to quickly just talk through how that works while you're experimenting? Okay, I'll explain how this works. So Facebook API, there's a specific API in the pages functionality within Facebook. So in order to deploy a bot, you have to create a page. You can't deploy a bot as an individual user. Okay, when you create a page, you can then go on to developers.facebook.com and you can request access to the messaging API for that page as the page owner. Okay, when you do that, you will establish a pair of webhooks, essentially, and you'll establish secrets, specify secrets or generate secrets for those webhooks. You end up with 2 webhooks. The webhook published by Facebook, you send a message to that in a specific format, and that message will end up in the messaging API for your page, okay, and will end up being delivered to a user that you specify in that message. You specify your own webhook URL within the Facebook console. When a message is received by your page, you will send a message to that webhook, which is hosted on AWS and is part of the Amazon Lex service. Okay, so there's 2 webhooks established here. When your page receives a message, you fire ours. When Lex wants to send a message, it fires yours. Okay, and there's a secrets exchange that takes place. This is all done within the Facebook console. There's one important prerequisite for publishing. To make your application visible to users, you have to have a valid privacy policy for your app. Okay, you have to publish that, and Facebook need to validate that privacy policy as part of onboarding your application as onto Messenger. Okay, using Messenger is about the lowest rung on the validation ladder that you can have, because the only thing you will get from users as a function of them using your app is their public profile and email address. You don't get any other data, so it's very lightweight in terms of the approval process. It takes just a couple of days. Once you're active with my bot, by the way, just say help or hello, and you'll get some information back about what it does. Okay, and then there are essentially 2 intents there: leave feedback or provide a rating. Many different variations of those phrases are supported, and I'll explain why and how I built the variations in a second. You can then either leave a score for this session of between 1 and 5 with some validation. You'll be asked for the date and the location, so say today in Stockholm, the session title, put whatever you want as long as it has Lex in it. And then you'll be asked to do a score. And if you invoke the leave feedback intent, it's the same, except that instead of providing the score, you're providing free-form feedback. You know, like, it was really bad, I hated it. That's my favorite one to get. Okay. And there's a little bit of stuff that happens behind the scenes with the feedback. Okay, so just do that, and I'll just take a look at my Facebook console. Excuse the cat pictures and stuff that will inevitably appear here. Okay, so we've got messages. Back over on my page here, and this is my messaging inbox. So, you know, you are interacting with the bot, and the interactions are streaming through the console, but they're also being responded to automatically by the bot. So you notice I'm not using the keyboard at this time, but you're getting responses, right? So it is definitely kind of working. So what is happening behind the scenes there? Well, we can take a look in the console at the intents and the language model that's been defined for this, just so you can see a little bit more about how things are working, okay? You see there are actually quite a few intents here. So there are more intents than the rate a session and provide feedback intent. There's, of course, a help intent, which allows you to get that help message or hello message that you first got. There's a cancel intent, so that anytime during the session you can say cancel and it will reset the session. Okay, so that's quite an important hygiene intent to have. There's a thanks intent, because I've discovered that a lot of people were saying thanks and error messages were being generated because this wasn't resolving. So over time I've created another hygiene intent, if you want, which allows it to gracefully respond when you thank it. It will say something like anytime, or no problem, or you're welcome, come back soon. Okay, so you got these hygiene intents that are just intended to make the experience more human-like. And then we also have a testing intent, which I'll show you in a little while, which allows me just to show one additional feature, which is kind of a nice feature to have for the touch interface. Okay, so we'll show that in a second. And then you'll notice that my utterance lists are quite long. You know, so I've got quite a few utterances, really trying to get my language model to be comprehensive and tuned, okay? How do you build that? There's actually a really nice feature in here in monitoring, which is the utterances feature, okay? Importantly, the missed utterances feature, okay? So I can find and see utterances that have not been picked up by the language engine. I'll go back to one where I know there's, I thought there were a few of these on 15, maybe not, 14? These are stored by version. Some of them might have expired, I think, actually. Oh, here we are. So these are utterances that have not been... It was testing data. No one's been mean to me. I'm being mean to myself. Okay. I'm looking for sentiment here, as you'll see in a little while. So having extreme comments is quite helpful because it triggers a sentiment engine. I'll show you that in a second. Okay. So what you're seeing here is unresolved intents, and this should give you an important clue. Okay. So that is obviously a slot value for the feedback slot, right? But it's not being resolved at the intent level. And this is important. The intent resolution engine is constantly active. Okay, so even if I elicit a slot, the intent resolution engine is still active at the top level within the language model. The reason for that is if it wasn't, I would never be able to cancel out of a session. I'd never be able to say cancel instead of saying the 13th of July. I could end up looping, and getting stuck essentially inside the interaction model. So the intent resolution engine is constantly active. Just be aware of that. But what you can do really is continuously review the missed utterances, and you can use missed utterances that should resolve down to one of your particular intents. You can quickly tag them here, okay, and then you can quickly add them to an intent. So this is how you can quickly flesh out your language model based on actual usage of the service. That is it's a simple, but it's actually a really nice feature. It allows you to quickly build up the language model, retrain the network, and quickly add more sophistication in intent resolution to your application, to your bot. Okay, so what else to show? So we have all that, and then we have our slots down here. Some of them are custom slots. So session feedback is a custom slot. It's a custom slot because we want here to capture free text, which is actually not really an intended use case. So you kind of got to trick the system into capturing free text for one of the slots. Okay, so this is something that I would say is suboptimal. It's not the optimal way to do this today. I need to enhance my code base to handle this particular use case in a slightly different way. I know how to do that. I just need to devote a bit more time to writing some tests and actually implementing it. So here I'm priming the slot resolution capability for that particular slot with a variety of natural language phrases. I can do that automatically, actually. I could harvest those unresolved intents programmatically from the API, and then I could inject them back in to the slot to basically build my slot cases out as well. So this is stuff that can be built around the core service with a bit of scaffolding. Okay, what else to show you? I suppose we better show you some results. Okay, so on results, let's show you the architecture first of all that gets the results, because that's probably interesting, and then we'll come back and quickly show you some results. So what is happening here at an architectural level? There are actually several different AWS services involved in this demo beyond Lex and Lambda. Okay, that's the first thing to say. So Amazon Lex, it's at the front end, you're interacting with it, slot resolution, session management, slot extraction, channels, in this case the Facebook webhook, but we could have others. Okay, we could actually have our own custom webhooks. There's a new Twitter API called the Account Activity API, which will hit a webhook each time your Twitter accounts receive a direct message. So we could quite simply build another receiver webhook for Twitter and call the Lex API directly from that webhook function and open up another channel, a custom channel, using custom webhooks that we design. I've actually got a prototype of that in another AWS account that's not currently working. Did I cut anything off at the back there? No, just my comfort monitor. Okay. No, yes, no. Sorry about that. Okay, probably be more careful. So that's the front end. Okay, then we've got our Lambda function. The code base for this one is quite a big code base, and I'll show it or share it later. Okay, and there's a few things that are happening. Obviously, we're iterating to solicit our slots. We have some random responses, like I mentioned earlier. So when we get that thank you API, thank you intent, there's actually a few different things we say. So at the moment, we have lists of responses defined inside the code base, and we're using random selects to basically generate random options from 5 or 6 different responses we have, just to try and make things a little bit more human-like, so we're not constantly repeating the same phraseology over and over again. So that's in the function. And then we have sentiment analysis in there. So when we receive the free text feedback, we call this new service we have called Amazon Comprehend, which is an API for natural language processing and sentiment analysis. We get a sentiment score back from that based on the contents of the free text. We enrich the fulfillment object with that sentiment score. And there are two different types of record, a sentiment score or a rating. We inject those into a Kinesis stream as JSON objects. Okay, so we're placing our fulfillment data into a Kinesis stream, and then ultimately we persist that back in Elasticsearch with a set of dashboards. Okay, so this is the overall architecture. Obviously, what is nice about Lambda is Lambda runs under an IAM role. So we're able to control credentials for access to these other AWS services within the Lambda function. It's a really nice security model. All it can do is perform read-only operations against comprehend to get results back from the comprehend data plane, and invoke the Kinesis API to put records. And it can invoke X-ray as well. I should draw that on here. So we have instrumentation in here in Amazon X-ray as well. So it's a fully blown serverless app really from that perspective that drives these different bits of functionality. The whole thing is managed within a service called AWS Code Pipeline. And that in turn is managed inside another AWS service called CodeStar. So my application is maintained here with its own CI/CD pipeline, its own version control, and its own metrics. So your usage of the app, you can see there 192 invocations of that function over the course of the last few minutes. That all comes out of this CodeStar dashboard, which supports the service. And then we've got a repo in code commit, which has the source code for the service within it. We can browse that. You'll see there's a SAM/CloudFormation template here that defines the different resources that are required for the app, including the IAM roles, the DynamoDB tables that are required there to be added to the functionality, Kinesis streams, delivery streams, even the Elasticsearch clusters all defined within that as a redeployable. So when I want to change the application architecture, I just change this template, that runs my pipeline, and that modifies the resources that I have. So it's like a full-blown serverless app as you would run one in production. And then on the dashboarding side of stuff, I'm using the AWS Elasticsearch service. And I have a script here which can allow me access to my Elasticsearch signing proxy. This Elasticsearch signing proxy runs a small Go binary which adds SIGV4 signatures to Elasticsearch requests. So our Elasticsearch service supports access keys and secret keys for authentication, and IAM policies to permit access to it. And to stamp or add access keys and sign requests, you need a proxy to sit between your requests and the service, which I have running here. Obviously, I'm using SSH port forwarding to access that, and I can go here and access the dashboard for the data, which is streaming off the bot. This should pop in a second. Internet here is slow. Or maybe it's Kibana. Okay, visualize. Dashboard. Okay, and there we are. So we got 14 people that interacted with the bot to provide a rating. Unfortunately, nobody invoked the feedback intent, so we don't have any sentiment scores to show you. The distribution of scores was mostly 5s and some 4s, and we averaged 4.51 in feedback. Okay, so that's the data from the session that you just ran. And you'll see the actual records are stored here. So these are the fulfillment records that come off the chat sessions that you had. So you all entered a score, a location. The date obviously is auto-resolved. And then we have your user ID. This is unique to your individual Facebook account. Okay, so we could call another API on Facebook and have that resolved back to your public profile. So when we say we're storing your public profile email address, we're not actually storing that. We're storing a token from Facebook which is linked to your public profile and email address. So we don't actually store any personal data in the system. And that's it, really. That's the demo, and that is the service. Okay, what else to say? And that's pretty much everything that I wanted to cover. Does anybody have any questions about what they've seen there? We've got a few minutes left. We've got like 11 minutes left. So does anybody have any questions? Yeah.
Supporting Swedish language for Amazon Lex. Is it on the roadmap?
We obviously have an intent to support additional languages, but I don't know when we're going to get to specific languages. Some of our newer services, we do have a service for translation called Amazon Translate. Okay, so depending on how you build the front end, you could actually put a neural translation service in front of this service and on the inbound and the outbound. What I've showed you here, obviously, is interacting with a channel, Facebook as a channel, but you can also directly call the Lex API from within your own apps. So, there's a few ways in which you could, and you can call that API with either a audio stream or audio file, or a text object. So you can send that API whatever you want. That means that you can support other languages today if you do the translation up front before you call the API. But we don't support it natively in the service today.
My second question about, so usually these solutions support short tail kind of question or queries, like booking a flight.
Yep.
How about like long tail queries, which is like more complex? Like NLU instead of just the extraction of parameters.
Yeah, so you can do that. There's a transcribe data type or transcribe attribute provided within the requests. Okay, so let me show you something. Hopefully I'll be able to find some historical data that just illustrates this. Just give me a sec. I'll show you something. Too many services. I should use the search feature. Let's go back. So this is all the logging data from my see if I can find the So this is the object that I'm receiving. Yeah, you see this? This is the object that my Lambda function is receiving when it is invoked by Amazon Lex. Okay, so I'm receiving a structure, a JSON structure that contains these attributes. One of the attributes that I receive is input transcript. An input transcript is the raw ASR. So the output from the raw ASR. Here I had an overly simplistic input transcript because I just entered B, and I'll show you why I entered that in a second in the other part of the demo that I forgot to show you, but I'll show you in a sec. So you can extract this input transcript attribute from the structure, and you can process that. So if you had an intent which was like, Google, how do I fly to the moon? Okay, you could figure out that it was the Google intent, and then you could extract the input transcript and you could send that to another engine. Okay, so you can use it as a native text-to-speech engine as well. Read the docs. There are length constraints on this that actually prevent the service from being used as a generic transcription service. Okay, but you can do shorter length input transcription that way.
I understand the answer. My question is like, does AWS offer such a service? For example, you input an article,
yeah,
and then you can query for answers, having an intelligent assistant without providing a question beforehand.
Not a complete answer is the answer, no. So we don't offer a complete semantic understanding service. We do have a new service called Amazon Comprehend, which I mentioned earlier, and I actually use one of the methods on Amazon Comprehend for my sentiment analysis. And that is a general purpose NLP service that will allow you to do document processing. You can see a very simple, a very simple sentiment extraction example here, where I'm calling the comprehend API with the string that is provided in feedback, and I'm doing this comprehend client detect sentiment operation, and that'll give me a data structure back that positive, negative, neutral probabilities for that particular fragment of text. There are other features within comprehend. It can do unsupervised topic extraction across a corpus of documents. So you can give it a large corpus of documents. It's a variant of clustering algorithm that will essentially pick out the top 100 or 200 topics within that cluster of documents without knowing in advance what the topics are. It will also do entity and key phrase extraction from documents. So you can give it a statement like, the weather in Washington State is hot and sunny, and it would extract Washington State as a location entity from that piece of text. But it wouldn't sort of convert it back into its basic meaning. You would have to write that on top of this topic, entity, and key phrase extraction functionality that we have. But it is a NLU service that is powered by a deep learning neural network, Amazon Comprehend. Okay. The other thing I was going to show you was the testing intent. I forgot to do so. So I'll just quickly jump back into Facebook. I'm going to interact with my own bot now down here. Make this a bit bigger. I'll totally be a picture of cats. So so we're back in interaction with my own bot now, and you can see that it is the same one. If I go help here, there's a feature for card generation, which is kind of cute. So I've got a testing feature which has 3 available valid responses, A, B, and C, but it recognizes any character of the letter, character of the alphabet as a valid slot, and then validates them down. And if you send it an invalid slot, it generates a response card. Okay, this is a specific feature of Facebook, but it's also available in Slack. Okay, in Slack's mobile client as well. It requires a slightly different response format to generate the card in Slack. So we have a general purpose card generation capability within our API. You can send the Lex API a fixed format document to generate one of these response cards. Okay. And then based on which channel we're going to deliver it to, we will transform the response card and deliver it in a format appropriate for either Facebook or Slack. Okay, and this is touch enabled. If you're using this on a mobile device, you can just press A, B, or C, and it will auto-generate A, B, and C as your response. You can see the same thing here. You can click on it there. So these cards are really useful feature if you are putting these applications onto mobile devices. I think they're really nice. Obviously, you can set the metadata up here. These are just examples. You can specify not only the values in the cards, but then the actual responses that are generated from those values. That's quite useful because you can have a human readable value here, but you can have a randomized token, for example, as the generated value, which means that you can make selecting a button from the card different from typing in the same thing in the chat, which is actually quite a useful feature. Sounds quite niche, but it's actually quite a useful feature. So that was the last thing that I wanted to show you was card generation. Obviously, one of the important things to know in programming, in this kind of programming model, is to understand these request response formats. And they are fully documented in this Lex developer documentation set here. And you'll find things like the request response format for card generation, the different dialog states that are supported, lots more examples of how you can do validation, as well as plenty of examples written in Node, as well as the examples that I've shown you that are written in Python. Okay, so that's all I have. Any more questions? Because we're almost out of time. Yeah.
So during intent resolution, we thought we saw there were misses. So I'm assuming it's not the exact match of the utterances.
No, it's a neural network. So it's a neural net. So essentially what it's using is a classifier, okay? And when you provide an utterance, it's running that utterance through a multi-class classifier, and it's selecting the intent that is the most likely to match it, okay? If we don't reach a certain probability threshold, then we'll throw the intent as unrecognized and allow you to retrain the model using that unrecognized intent, or build a new intent if you've got intents, utterances that don't fit one of your existing intents. So it's using a multi-class classifier at the back end. Say again, sorry? Yes, it accounts for, I'd say, less typos and more how the word sounds. So if I write to or two the wrong way, it'll know about that. But if I misspell to, O-T-O, then bets are off. Okay, so it accounts for phonic typos, let's say. You know, yeah. Probably, but I don't know what it is. I'm sure that if you need an answer to that question, you can contact us. It might be in service limits in the docs, so I'll quickly take a look at that. Say again? There isn't really a base number. You define. You're talking about for intent resolution, so how many intents? I've seen 50 in one example Q&A bot that we have running around internally, where each topic is a different intent, so asking a question about 50 different things being supported quite happily, so I presume you can go higher than that. The best way to check that is to look in the docs for service limits, and then you'll see it. Maybe search for that. Wow, internet's really slow. Yeah, so there'll be a section in the documentation about service limits, and you'll probably, yeah, it's not going to play. You'll find it there. Okay, we're out of time. Oh, go ahead. One last question. I don't know of a reference that's doing that. I know of plenty of app developers that do that. One of the ones that I know about, and I don't know whether they're on AWS, so this is neither a statement that they are or a statement that they're not, but there's an Uber competitor in China called Didi, which has neural translation for English to Chinese, and certain operations within their application are serviced by a bot as well, so that you can either talk to a driver and have neural translation in the flow, but some of those interactions are auto-responded to. So they must be using something like this, but I do not know what service it's built on under the covers. So that definitely can be done. Yeah. Okay, great. If you didn't mess around or interact with the bot during the session, feel free to do so. Just search for ian.massingham.aws on Facebook Messenger and like my page, because I am trying to generate some page likes as a result of this activity. So like my page, and also let me have your feedback. Let me have your long form feedback as well, because I need some more utterances to train my model. Thank you.